And with that, I'd like to invite Thomas Beale, who is the specification lead for openEHR, to talk about what this future is. Thank you. And of course, any questions, more than glad to answer.
Testing. Good afternoon, everybody. Thanks for having me here. It's been a very nice day of fascinating presentations. I've learned a lot about open air today. Must come to more of these days. It's a Mac, so I'm only half capable. Give me back my Solaris. That's what I still yearn for. It's showing age, isn't it? With either a microscope or a telescope. Yeah, that looks good. Does this
Oh, no, that's not. That's, no, they've got the horrible screen, and we got the...
Oh, yeah. Oh, God. This is what happens when you put a clinician in charge of technology.
Swap displays in the top. Swap displays, have it? Yeah.
I've been waiting to be able to say that about him in front of 80 people for years. Don't normally get that opportunity. Yeah, that's good. I don't know what I'm seeing. I'll just talk to one of these walls. Okay, right. I'm going to talk about something we called task planning. So what is task planning? I actually can't read that. That's the old macular degeneration, isn't it? So it's something to do with workflow. Workflow, no pressure. So getting into workflow in health is a kind of, I don't know, it's either totally insane or partly insane, and partly insane might be like being partly pregnant, so I don't know if either of those are a good idea. There are some possible responses to this question. We might be completely mad because it can't be done. Clinical processes too complicated. Not totally routine clinical processes, but anything that's clinically a little bit complicated or runs over a long time or has a care team involved. They have their own types of complication. If we look at care pathways, guidelines, care plans, there are different categories of artifacts and representation, for clinical people and organisations that we're, trying to potentially integrate into a working, healthcare delivery for a patient. But anybody who knows about these things will know that they've all got their own internal complexity and they're all used in different ways. So how do we make all of that work together? So maybe it's just too complicated to do properly. Another response might be, well, it's already been done. Depending on what room you're in and what sort of people you're talking with, you sometimes get some interesting responses. Well, we've got BPMN, business process model and notation. There's a case management modelling notation. I think I got that one right. A decision modelling notation, I think. I might have got the M wrong there. Anyway, there's a whole bunch of things that have been published in the IT world. That's those middle things. YAWL, by the way, happens to be the one that really matters. That's the one that's really well done. In the healthcare domain, well, we already have lots of published guidelines. We have the things that you can find on the NICE website, and every country has its own kinds of those things. If you go to the big American hospitals or Kaiser or somewhere, you'll find they've got lots of beautiful, serious guidelines and clinical process models for all kinds of conditions. In the health informatics world, we've got various formalisms, Arden, Glyph, Asbru, Proforma. Some of these are being used. The middle set that I mentioned at the beginning, certainly heavily used in industrial process and automation, and organisations like Amazon and the big mailing FedEx, those kind of organisations, they use them heavily to move stuff around the place that arrives in a package at your door. There's a reason why that works, and that's because a package, you know, a book in an Amazon wrapper is a completely a passive object, and it's just being shuffled around. It doesn't react to drugs. It just sits there. You can build a BPMN diagram that says what's going to happen to that package through, you know, the various centres, and there are unknowns and there are exceptions, but they're kind of known unknowns, to use the infamous terminology. You know, a vehicle breaks down, the plane that's carrying the book from Germany to the UK is late, etc., etc. But they know what the categories of things that can go wrong are. So I would, and I think we can probably agree that we have to do something about process support in the clinical world, well, because it's too complicated. So I've spent the last year and a half in segments working at Intermountain in Salt Lake City, Intermountain Healthcare, and that's a very big hospital. Well, it's a hospital group. It's not big like Kaiser, but it's got about 20 hospitals and I think a couple of hundred clinics. It's also very well known for its health informatics expertise, and Dr. Brent James, who's the head of clinical quality there, is a world expert on clinical process and particularly the problem of complexity. So I'll talk a little bit more about him and, you know, some of the things I've learned at Intermountain. But just to say that the complexity is what defeats the human mind. So the very simple way of understanding it is that, and I'm sure you've all heard this before, humans are good at remembering in the short term about 7 things, or 7 plus or minus 2. That's the usual idea, between 5 and 9 things. But if the patient in front of you, maybe a sepsis patient, is, you know, somewhere on the journey of being treated for sepsis, maybe you're not even sure if it is sepsis, then there can easily be more than 9 variables in play, and if there are, then you'll probably, you know, you're going to do wrong things. Even though you think you're doing Harvard Medical School level medicine, which you probably are, you can still do wrong things. And Brent James said to me one day when I was there, you know, actually what we learn when we look at what goes on inside big hospitals with people who've been trained at, you know, places like Harvard Medical School is we're killing and injuring patients left, right and centre. And that's a very hard thing for, you know, totally dedicated hospital docs particularly to deal with. Team-based care is becoming the norm. We have complex conditions. So, I mean, even birth can be complicated, and it can get complicated fast and life-threatening fast, and a lot of things can be like that. So the routine can turn into the non-routine, you know, easily enough. The evidence shows, this is from Brent James, that the best predictor historically of success in complex cases in some of the best institutions is which medical school and year of leaving. What? So, even the best doctors don't do medicine very well. Now, how can this possibly be? Now, this is the world of evidence-based medicine. This is what happens when you study the actual results and you be objective, and nobody's, you know, looking for the bad doctor, because it's not about being a bad doctor. It's about complexity. So the right process is often only discovered by examining numerous cases and reverse engineering good process from good but scattered results. So this is where things like care pathways in, you know, nice and similar institutions come from. They come from studying things. What they come from studying actually is the situation, same docs, and I mean the same level of training and experience and so on, plus the same patients, that is the same admission situation, equals different outcomes. And not just slightly different outcomes, but majorly different outcomes. How can that be? Well, you go and study all of those cases and you realise that there are bits of things that every doctor and patient combination, well, normally the doctors did right, but those same doctors did something, a potentially even fatal error, you know, a bit later on. Some other doctors over here got the first bit wrong, but not too badly wrong. They got another bit slightly wrong over here. They did something fantastic over here, which these guys, if they had done that, the combination of everything done right would have been good. Nobody does everything right, and the study of these cases, you know, provides the basis for building good quality care pathways. And then you have something that you can follow, and human beings can't do it in their head because of the 7 plus or minus 2 problem. Now, Dr. James said to me sometimes it's I said, well, how many variables can there be? And he said, in some cases there's 40. So, I mean, some of the doctors here might have, know better than I do, but I'm sure you'll agree that it's not always going to be less than 7, for example. Do we need to computerise things? Well, if you look at NICE, you'll see care pathways, and they're, it's pretty fantastic work. You've got a clickable website. You've got a lot of clinical usable detail on the right-hand side. Isn't that good enough? This is from Intermountain. This is acute ischemic stroke. So they don't have a clickable website. They've got things that are still printed out on PDFs, and they're in a ring binder on the side of the bed. And if you have a look, you'll see some very detailed information here. I mean, this is heavily designed. This is probably version 15 or 20, or I don't know what. And this is just a little bit of a decision pathway here. There's a lot of details here. There are numbers all over the place. So as doctors, and anybody who knows about this kind of stuff, you'll realise the numbers and some of these decision pathway details can change. That's what evidence, if the evidence says that it's got to be different, that can change. There's another little bit that's got some times from the so-called stroke clock, and a bit more workflow. There's a whole stack of details, warnings and precautions, contraindications. So there's a lot of bits and pieces here. There's particular numbers for blood pressures and times for recent types of surgery and procedures and so on, which would prevent you doing something. And well, what if those numbers change? They obviously could change. So there's no way anybody can internalise all of this. Even if they get it right and they've got a fantastic, perfect memory, it's going to be different in 2 months' time anyway. So, challenge of complexity and continually evolving science. Also from the same guideline, you'll see 1, 2, 3, 4, 5, 6, 7, roughly 7 different types of people who could actually be 7. At Intermountain Healthcare, they are 7 different people, all coordinating what they're doing against the stroke clock. So you're trying to get everything done at the emergency level inside about 3.5 hours or something like that. So there's a coordination problem there, and a handoff problem, and a communication problem. Another difficulty, care pathways are for model patients, i.e. one condition, sepsis or complicated childbirth or whatever it might be. A real patient is a body, somatic individual. It's an individual phenotype in terms of what I have, genetically expressed phenotypically, and then the history of things that have been done to my body. There's usually multiple conditions, even if it's just pregnancy plus something else, or being mildly, type 2 diabetes or whatever, and the main thing that I'm in hospital for. So care pathway in general isn't a direct recipe for caring for the patient. So even if we can computerise, things that you see on NICE and put them on a screen, and I have seen attempts to do that at Intermountain Healthcare, that doesn't give you a process for just caring for a patient, because the patient has, just drug interactions and allergies will just stop you halfway through, because the drugs there have to be actually compared against what the patient's already on, to just take the simplest possible case. Mundane reasons why we have to computerise process to some level. Just medication management. Well, that should be easy, right? Well, we have shifts, we have staff changes. How do we know what we already did? Like Angie said, it's easy to forget because somebody, was talking about the weather in your ear or whatever. How can we plan ahead of time and notify workers? So this notification question and this planning question starts to become interesting. So there's a little chemo, a design of a regime, which all the doctors will know. The dosages have to be computed through, these are formulas for dosages. You've got to convert them to real doses based on the surface area, so you've got to do a bit of computation. Anyway, you've got, yeah, there we go. So certain days, there's things to do on day 1, things to do on days 1 to 3, things to do on days 1 to 5. You can see there. And, what are they? Well, we've got to get all the doses right. We've obviously, got the drugs. What's the method of giving them to the patient? There's another one. So there's a bunch of, the same type of information. Again, we have, day 0, day 1 to 4, etc., etc. So there are things that we're doing that are mundane, but if anything gets done wrong, double dose, misses a dose or whatever, it's probably going to be, it could be catastrophic for the patient. And chemotherapy medication errors are unfortunately a well-known category of medication error, and it's because of mundane reasons of handovers and people, it's not the same person sort of 5 days in a row just sitting there with nothing else to do, obviously. So that last one, what does that look like drawn out as some, you can imagine maybe start thinking in terms of tasks. So each block represents something to do at a certain day. So there's the days across the top, there's the drugs down the left, okay, and then, I mean, I've just made a Mickey Mouse, cartoon representation. If you went onto an oncology unit, you'll see undoubtedly applications that do this properly, but they'll be oncology-only applications because of chemotherapy being its own thing. They won't talk to anything except their own silo of data. That's one of the questions we've got here. They also won't allow you to do the planning concept, and this is just a time planning concept. You can't take that application that might do chemo today and go and plan, I don't know, rehabilitation therapy for an accident victim or something completely unrelated. You're just going to have to buy other software for that, or do it on paper or whatever. We'd like things like, what have I done already? What is there to go? So if this was done as a proper application, you can imagine how much smart stuff would be on here. Maybe colours or all kinds of things would represent, for example, 24-hour infusion, maybe the width of the blocks, etc., etc. But what we're after is a model of workflow and planning that works for everything. Chemo is just one example. Other requirements, order sets. Well, chemo is a perfect example of order sets. So the question is how to connect the order sets, items together, and the slightly wider care plan process elements. Long-term treatments. So again, changes in staff, locations, units, institutions, everything changes. The only thing that doesn't change is the patient and the actual treatment itself. There's an idea of a checklist, sign-off kind of view of things. What have I done? What have I got to do? And being able to know definitively, yes, the patient did have that drug yesterday at a certain dose, and here was the person who did it, and there's just no doubt. We probably need, well, we definitely need decision pathways as a conceptual element of a planning specification. If then else, that kind of logic. Computer scientists tend to think also in terms of what we call case statements or switch statements, an expression, and then the possible values, the ranges. Could be weights, could be blood pressures, could be any other vital sign or platelets or anything you can think of. When then rules, it's like a wait state. When X happens, do this. When Y happens, do this. When Z happens, do this. So these are all, I mean, I've made it sound a bit computer, programming, but actually you clinical people are doing this all the time. You're not even thinking about it. It's just normal thinking. What about adaptation? This is the big killer for clinical process automation. I want to skip a task, I want to cancel a task, I want to abandon a plan, I want to maybe cancel a task but not abandon the plan, I want to retry a task because something changed and I got a new result that means I can go back here. I want to override preconditions because I know better, and even though the plan was designed in a good way, the doctor knows best at the end of the day. Actually, something I didn't mention on here, but one of the design principles we've actually built in is the idea that the the task planning system is like a co-pilot, but it's just like you in your car with, you know, the Garmin or whatever. At some point it goes, or you tell it, you know, buddy, you're wrong. There's roadworks there. You haven't caught up. I'll be doing my own route, thanks. That's because you know, and it doesn't. And that happens all the time. Could have helped a few tourists avoiding favelas in Brazil, which is a place I spend quite a bit of time, but they would have had to have the special knowledge to override the co-pilot. Other requirements. Task list for a worker versus task plan for a patient. It's not the same thing. The task plan for the patient is something that's you know, a set of steps and so on for the patient. The task list for a worker is, what am I doing today if I'm a healthcare professional? What I'm doing today for that patient isn't the totality of what I'm doing today. All of what I'm doing today is, you know, 28 patients or 5 patients or whatever it might be. So there's what I'm doing for that patient, there's what everybody's doing for that patient, and then there's what am I doing today. So there are different levels of plan concept. Costing information. What about analytics? Analysing current process and extracting, you know, it's called process mining, extracting knowledge from the way processes have been executed currently and taking that knowledge, examining, etc. To do that, you need to have computable process information. So I'm sort of just running through a whole scattergun list of requirements and, you know, trying to horrify you in a little tiny way. Or if you're a clinician, you're just thinking, yeah, you know, I kind of understand. That's why we don't have any stuff that really does this properly, unlike DHL, because it's just a box, you know, going into a, you know, this sort of stuff. Patients don't work like that, do they? So I'm just going to take you through some of the design principles of the task planning specification that we've built. It's in its early days, and I guarantee you it's wrong, because I know it's not 100% right, so by definition it's somehow wrong. And it's going into implementation, so we're going to find out where those wrong bits are, and it'll, you know, undergo a little scientific process of adjustment. So I'll just give you some of the principles. The first thing is we've got a distinction between care pathways, so that's the nice kind of stuff. Care plans, which I don't know if anybody really agrees what they are, but every doc knows what they are in the sense of just using it or making one. And what we've called task plans. So the specification that what I'm talking about, and, you know, the new specification openEHR, is just about this piece for the moment. We have theories that the representation of task plans, what we call task plans, so concrete pieces of workflow and plan information, we have a theory that some of the representation, maybe a lot of it, will be the same representation as care pathways. But I'm not daring to go and make any claim today that, you know, we can grab something off the NICE website or, you know, the Swedish equivalent or whatever it might be and just say, oh yeah, we can represent all of this, because again, if you look at it, you'll see it's very, very dense, semi-formalised, semi-informal. It's, you know, it's not to be messed with unless you're going to really get it right. So this is where we're starting representation-wise. Next thing. This might be the most obvious thing in the world, except to computer people who somehow often think that everything is only in the blue area, which is the computing environment. What's running inside computers? Well, docs know that they're working in the real world. There's a patient, and there's drugs, they're in the ICU, there's monitors, there's whatever. Everything that's happening in the real world, all of the care is going on inside their minds. Maybe they're looking at screens and, you know, they're interacting with technology and so on. The key thing is that any sort of workflow tool or system is running inside a computing environment, and it's just an attempt to synchronize with reality and to help people in the real world do things and not to miss things and so on, to get drug dosages right, whatever it might be. So there's an imperfect synchronization here. That must always be remembered. The next thing is the performers of the plan are, generally speaking, people, or maybe they'll be robots or machines or software, but we have to consider them as separate agents in the real world, separate from this task planning or workflow system. Even if it was a piece of software and even if it was running on the same infrastructure somewhere here, conceptually it's actually more like a person down here. All of this could be driven by, some published guideline or protocol. So how we design the work plans, may come from some nice published stuff. If we can eventually represent the published, care pathways in a computable form, then we can start thinking about something very exciting, and that's generating workflow, work plan definitions semi-automatically from formalised care pathways. That's kind of chapter 2. As Tamaj or someone said already, task planning we conceive as more as a co-pilot. Where the car is where the care process is currently at. Destination is the patient goal or target, and we're always recomputing from here. That's the adaptive aspect. So we're trying to build a continuously adaptive patient journey navigation system. Sounds simple? Other principles. Workflow, decision support, and the EHR are intimately related, and I really learned this at Intermountain Healthcare. I didn't think about it enough, I must admit, over the last 15 years, but it's much more like do a bit, decide a bit, record a bit, do a bit more, decide a bit more. It's just all mixed up. Now, it's a cognitive loop. That's what's happening with a bunch of doctors, or it might be just one doing something. But that's what's going on, and we'd like to make the record a bit almost invisible. In other words, data going into the EHR we want as a kind of nice side effect of everything happening. Okay, next thing. A basic choice in the task plan architecture is that it's executable in the sense of all elements used in creating plan definitions have an objective, computational meaning and can be executed according to defined semantics. Now don't forget, the task plan doesn't do the job. It runs and it delivers notifications and might request data. It talks to people in the environment and reminds them to do things. So it's the totality of the humans plus this thing running in the centre that makes the healthcare happen. But my point here is that if we have some nice diagram representing a task plan, it's not ambiguous. It can be executed by the engine and it can do that reminding and putting stuff on the screen, and there's no ambiguity about that. Why do I say that? Look at most BPMN diagrams. They're full of crazy English, a little bit formalised, not formalised stuff, and you look at one of the boxes and actually you realise that it's not computable. Now you can build very well computable BPMN2 models and you can execute them, but it's easy to build non-computable ones. So we are in the realm of making everything 100% computable. Otherwise, what's the point? So we want the development of task plans to be a kind of high-level programming, performed using dedicated tools and whose resulting artifacts are executable, also reusable. Now, I don't have any time to show, but in Intermountain Healthcare, they've built exactly this kind of environment. It's got a more limited range and less semantics than what we're building here, but they've got a tool that takes its archetypes and templates and the process plan on top of it. They press a button and they get an application that has all of the process workflow built into it. And they're going deep in radiology, certain types of nursing and so on, also speech recognition, all working beautifully. It's fantastic work. So that's inspired me a lot. I mean, we're already doing high-level programming with archetypes and templates and so on. We're just trying to get to the next level. All right, so very quickly, a little tiny bit of architecture. The concept is there's a task planning engine. It's got a plan execution context. Inside there is a work plan made up of a number of task plans. Each task plan is for one principal, what we call a principal performer. So this is where you get teams. A work plan can correspond to a team. If the team is one person, then you've got one task plan. there's a design tool, so just think archetype building tools on steroids that have, eventually very highly adapted user interface that corresponds to process type of concepts. We assume that the system, that is the task planning system, will be able to talk to external systems, so external computing systems, services or whatever, through APIs which are known or knowable. We assume that it can make external requests in a more generic way to external organisations. So this is much more like sort of email or even generating SMSs or just generic comms outside of the whole computing environment to another, probably another company, in fact, a lab organisation, for example. We assume that we can listen, or it's possible to put systems that can listen to events, notifications of events that occur inside this environment. So what's going on inside here is execution of plans in real time with, it says planning application, it really means plan-enabled application, an application that is, maybe the chemotherapy example or whatever. But now what it has on the screen is heavily driven by what's going on inside the engine. And our real people are down here in the real world using those applications. So that's just the overall concept. So there's a little bit of language here, external system calls, external requests, and so on. There's a problem of levels of representation. I won't even go into this except just to say that it exists. In workflow's definition, you have to have a definition. You have to, well, let's just go back. In openEHR, we can do something nice. We can use archetypes and templates to give us one level higher than a concrete definition because we want to be able to have categories of workflow. For example, any chemotherapy, and then certain types of chemotherapy for leukemia or whatever it might be. We can do all that in archetypes and templates based on the task planning model. We can instantiate that. But now, instead of instantiating archetypes to get clinical data, which is what happens if you instantiate the archetypes that are to do with the normal openEHR reference model, now you get a task plan. So that's a different kind of artifact. It's still a sort of a plan concept, but it should be patient-specific. We're still working out exactly at what point does it absolutely have to be nailed down to a single patient. To actually execute the plan, we have another level of instantiation we call the materialized definition. And I'll just give you a simple example as to why they're different. In this definition here, it might be that there are repeatable constructs or blocks of work. A week worth of medication could actually be repeated indefinitely depending on how the patient goes. At that plan level, we just want that 1 week and its internal tasks represented, right? At the level here, we want to actually unfold that. Maybe the clinician will say, well, I want 4 weeks of management of this patient using that 1 week regime. So give me 4 weeks, and that will unfold into actual 4 weeks of tasks in time. Now, a materialized definition is an executable definition. If we're managing a diabetic patient, well, it's 1 week, 1 month, 1 year. We're talking long time spans where that particular plan might be operating. But actually, when there's nurses or other healthcare professionals with the patient, that's minutes and hours, and then the shift changes or somebody goes home. So there's when are the applications on the screen. There's the time of when the plan is executing beyond just sessions and work periods and so on. So there's actually 2 levels of runtime representation to think about. Things like speech recognition and real-time interaction happen with this runtime instantiation here. They don't need to happen on this one. So an application is talking to, if you like, a little slice in time of a task plan that corresponds to, right now or the next couple of hours or whatever. Maybe the next week it might draw up the next week's worth of drug administrations. So very roughly, there are the three levels of runtime representation. The definition, we materialize, we get the materialized form, and we've actually called this activate. When it's when this gets activated and it starts being used, and then we have the runtime user session level. The model has something which allows us to record the execution history. Every single thing that is done in this task plan that's received as a signal by any user or any device in the overall ecosystem is recorded, so you can replay the whole process. So that's in the model. The basic structure is the concept of a work plan with multiple task plans. Each task plan has a principal performer, and usually at the archetype level it's going to be defined by role, and those roles are going to get filled at runtime by some sort of selection process. Different types of tasks, so we have a taxonomy of tasks. The key thing is a performable task, a locally performable task versus a dispatchable task. So there's a task that's in the task plan that's something I can do. Take the blood pressure, review whatever it is. Or it can be a dispatchable task. That means something that has to be sent to somebody else. It could be another worker in the same work plan. It could be a whole other organisation that's going to give me it might be radiology or the lab or whatever. So the concrete kinds of tasks, on the right-hand side, locally defined tasks. So that's a task saying, right, what have I got to do? That's probably the easiest to understand. And we can archetype all of that with prototypes of observations and actions and so on that we're used to having in openEHR. A subplan, that just means I'm going to go to a more detailed level, but it's still something I'm locally performing. Subplans give us the ability to click plans together like Lego blocks and to reuse this piece inside two other plans. Then in the dispatchable task types, we've got external system request to a request to external system, a request to an external agent, that's another worker, and a handoff within the same work plan. So this one here, the second one, is not in the same work plan, just another external worker. So that's the task types that we have at the moment in the model. We have the concept, I know this is going to sound a little bit IT, but context switching means I'm going to stop and wait and you're going to do something. Maybe you're going to do the CT scan for the stroke patient. I'm just going to wait. Well, not really. I'm going to do something for another patient, but with respect to the first patient, I'm essentially logically waiting, and you're going to do your stuff and then ping me back. That's a context switch. A context fork means I'm going to get you to do something, and I'm going to keep doing stuff. I'm going to keep stabilising the patient or finish the intubation or do whatever, but I've pressed a button and got something, maybe took a little sample or some vital signs, got sent to some other specialist who needs to do something with it. We need to handle callback from when the ball gets passed to the other worker. How do I know that that guy's finished? It might be that I don't care because that's the nature of the plan. It might be that I do care. But I'm with patient B now. How am I going to find out? So we have to have a notification coming maybe into the pocket, maybe a beeper, whatever mechanism in the human world has to say, you need to be doing this because that task is finished. Now, it might be that you don't really need to do it right now. So, of course, we have the idea of time windows in which you can say, well, as long as it's within half an hour of the receipt of this, you'll be fine. But at some point at the end of that half hour, there's going to be an alarm of some kind, and somebody's going to say, you really have to go and take care of this guy again because, the clock is ticking. I'm just giving you an idea of all of the things that we have to take care of in the model for task planning to make it work. And I can tell you quite a few of these aren't in BPMN. I like a lot about BPMN. It's just doesn't do this kind of work particularly well. There's a task life cycle. A single task, this is a big difference from BPMN. We can have a task that is planned, it can be in the available state, it could be underway, it could be completed, you can cancel. There's a whole lot of things you can do. At Intermountain Healthcare, where they've already got an implementation, they'll have rows on the screen of different tasks, and the first one will be available, so it's in black, and you can do something to say you've done it or you're cancelling it or whatever. When it's completed in some way, the next task highlights, it goes black, and you can do something with it. If the tasks are parallel sets of tasks, meaning you can do them in any order, then they'll all go, and you can just pick them in whichever order and sign them off, cancel them, cancel and abandon. So again, I hope you're getting the idea that there's a little bit of complexity that we had to take care of in this model. Allocation is a thing we have to do properly. BPMN doesn't really deal with allocation. It's one of the things we learn by studying YAWL. YAWL stands for Yet Another Workflow Language. Just very briefly, tasks can be allocated to two types of things, individuals and worker pools, like nursing stations, that kind of thing. We have to connect workers at runtime with the sort of requested allocation. So somebody has to either claim a plan or accept a task. There's a lot of stuff in the model about events, different types of events. So they're roughly classified as time. We treat time as an event. What it means is, imagine the clock is always ticking, and on the clock time you've got tasks at a certain time. So when the cursor goes past that, it means ding. So it's just like your alarm on your iPhone to wake up in the morning. That's an event. And we can have events from task transitions, like another task completed can generate an event that can be used as a trigger for another task to be started. External world events, patient state changes, heart rate goes above a certain level, some other vital sign changes in a certain way, etc. A performer, a human being, or not even, it could just be anybody, tells the task planning engine something. We received a lab result, maybe even on paper. Another system tells the task planning engine something. I'm getting near the end. I'm basically just trying to scare you into, total silence. What does execution look like? Okay, the work plan gets activated. Each principal performer has a task plan. If it's a team situation, one principal performer equals a... You can have other performers as well, it's no problem. That's allowed for. Tasks are displayed or notified, like I just explained before, and this life cycle applies. Often you're waiting on various kinds of events before something becomes available. We can do things like retry, redo, not needed, can't complete, etc., etc. Very quickly, just for people who already know about openEHR, you know about instructions. That's openEHR's way of representing orders. You know about actions and observations. So actions are openEHR's way of representing what got done in response to an order. In other words, drug administrations or some other therapeutic work intervention of some kind. And the missing thing that the task planning model fills in is the whole concept of planning these tasks before they're done, but according to what's in the instructions. Now, just a very simple way of distinguishing this in your mind. What's an instruction? Well, it's something like, if you just think of something really simple, like what's on the box of medication, 3 times a day oral with meals or without meals, whatever it might be. That's actually a little algorithm. A human being has to interpret the 3TDPO 7 days and go, oh, right, 9 a.m. Monday morning, that's the first one. 1 p.m. after the meal, and you keep going like that. So if you do it out like a, maybe if you're going to draw it out, explain to your child what daddy as the doctor does, you could draw it out like that and the child will understand, and eventually they'll understand that the order is a little algorithm. So one of the jobs that we're actually trying to do is to turn the algorithms of orders into the simplistic set of tasks drawn out in time that can be checked off, not because we're children, but because we're nurses or docs and constantly going in and out of the hospital and visiting different patients. We just need to be reminded, what have we done, what have we still got to do? So that's the added piece. The whole task plan can actually be driven by care pathways, and that's certainly where we're going. Not everything in the task plan has to come from an order. It might just be something that the pathway says to do, but there's no order for it. So the roadmap is Moscow City implementations underway. We're actually probably, well, we started building a visual language, and that's possibly one of the points of insanity, but we feel like we probably are going to do that. We did think maybe we can just reuse in a sort of hijacking kind of way, BPMN or CMMN, and we might still do it. I'm not against it, but we'll see. We're testing archetypes for various task plans. So we've got some example sites. The biggest one, I suppose the one that's in the heaviest implementation is certainly Moran's one in Moscow, mainly polyclinic workflows, I guess. DIPS in Norway, in their arena system, they've got a lot of hospital workflows, and they will certainly be doing some of those in the task planning approach fairly soon. Tieto, another recent player coming into openEHR, they're actively tracking it, and they may go to implementation at some point as well. So there's the link to the specification. There's a little bit of diagrams of our initial visual language, and that's it. So I've shattered your brains all into silence, and some of you are asleep, but I feel good about that. Given that, like the person who was before lunch is between the crowd and the lunch, I'm between the crowd and the beer or the wine or heroin or whatever they've got out there. So thank you for your attention.